Alright, we're going to continue talking about exponential functions today. As with the other videos, it is expected that you have the 4.1 notes in front of you. We have talked about exponential functions in the form of f of x equals a to the x. And so it's worth just mentioning, right? We have f of x equals a to the x. And we said that it had a couple of important points. This will always have the point 1a, and it will also have the point 0, 1. Now, the reason those 2 points are important is because when we start to transform these functions, when we take a exponential function and we transform it by either stretching it or shrinking it vertically, we end up with something of the form f of x equals c a to the x. And for the purposes of this, c is a positive real number. We call c the initial condition. And we call it the initial condition because c is the value that this function will take when x is 0. Regardless of what the value of a is, if we take f of 0, ca to the 0 equals ca to the 0, notice the a to the 0, it is 1. As we said earlier, anything to the 0 power is 1. So f of 0 will always equal c. This means that the point 0c will always be on the function. The other point, and that goes along with the 0, 1 point there. The other point that we have is going to be the point 1ac. Regardless of what the value of a is, regardless of what the value of c is, if I plug in f of 1, that's going to give me ca to the first. So the point 1ca will always be on the function. Let's look at an example. Let's consider the function f of x equals 4 times 3 to the x. So in this function, we can see that the initial value, right, c, is going to be 4. And since our base is 3, that will be the value of a. So in this function, c is 4, 3 is a. Now, if I plug in f of 0, I'm going to get 4 times 3 to the 0 power, and that's going to give me 4 times 1, which is 4. c equals 4. If I plug in f of 1, I will have 4 times 3 to the first, which would be 12. But remember that c is 4, so this is c times a. We also talked about functions of the form f of x equals a to the negative x. And we said that 2 important points that we found in this function are the points 0, 1 and the point 1, 1 over a. When we multiply this type of function by a constant, we end up with values of 0c, and which is the same as it was with the a to the x. What is different when we have a to the negative x instead of a to the x is that now we have 1c over a as the other point, which is very similar to what we had over there in the when a is 1. As a quick example, if we have 3 times 2 to the negative x, just looking at our two important points, we know that, sorry, getting a little blurred there, right? We've got f of 0 equals 3 times 2 to the negative 0, which is negative 0 is still just 0, so 2 to the 0, that's just 1. So f of 0 is 3. That's the point 0, 3. And notice 3, that would be the c, right? So there's my 0, c point. If I plug in 1 to this function, f of 1, we will get 3 times 2 to the negative 1, which would be 3 halves. We have already identified the 3 as the c value, and we know that the 2 is the a value, so this is of the form c over a. So my f of 1 value works in the same way that we were just talking about. So if we're given values and we know that this is an exponential function, understanding those two important points will also assist us in finding the actual function that is associated with a table of values. Again, the two important points are the 0 point and the 1 point. So long as I have those, it is a very straightforward process to find the function that we are looking for. So in this case, we have the two important points that we have are 0, 3 and the point 1, 15. Now, keeping in mind this is an exponential function, so this point is the point 0, c, and so we now know that c equals 3. Since this is the point 1, ca, we know that c is 3, so that's going to tell us that 15 equals 3a. Divide both sides by 3, and a equals 5. That means that this function should be f of x equals 3, that's my c value, times 5 to the x power. And notice, to go from 0.12 to 0.16, we multiply by 5. To go from 0.6 to 3, we multiply by 5. 3 to 15 times 5. So to go to the next value in that table, every time you are multiplying by 5. We know that it is of the form f of x equals a to the x. We picked this one because it is an increasing function. So because our x values go from small to large, and we remember that f of x equals a to the x is always an increasing function, where f of x equals a to the negative x is a decreasing function. So since these values are increasing, we know that we use the c equals a to the x form. Here's another example of a function. Now this time notice that as we go from left to right, we are decreasing every time. And so this is going to be a function of the form f of x equals ca to the negative x. And so the 2 points that we are going to be looking for, sorry about that, in this problem are going to be the point 0, a, 0, c, sorry about that. And then our other important point will be the point 1, c over a. And again, we know we are in this form because this function is decreasing rather than increasing. So in first point we pick is that 0, 2 point. That's going to give us c, oops, sorry. c equals 2. Then the c over a point, right, that's going to be our 1 point. So we've got 0.5. So c over a equals 0.5. And that's because we have the point 1, comma, 0.5. So a times 0.5 equals 2. Let me show you how I got that. All right. Instead of the c, right, we know that c is 2. So 2 over a equals 0.5. 0.5a equals 2, a equals 4. And so our function is f of x equals 2 times 4 to the negative x. And that is how you find exponential functions from a table.